So hello everyone. So first of all, thanks for the organizer team for bringing such a Ethereum community event to our lovely city. It's great to see a community flourishing here in Istanbul. And today I'll be talking about the Ethereum's Rollup-Centric Roadmap. And it's the official, certified, top-rated roadmap by me, not the Ethereum Foundation. So these are like my takeaways and my opinions about how I see it's evolving. And those are not official stances of the Ethereum Foundation. And also, there's actually no official news in Ethereum. So it's not an official thing. If someone says it, it is official if the community chooses to move in that direction. So keep that in mind. Ethereum is not there's no official thing in Ethereum. But obviously, there are people you look for what they're saying. And another thing, since we are in Istanbul at an Ethereum event, I would like to bring your attention to our proposal for the next DevCon. If you don't know, DevCon is the largest Ethereum event organized by the Ethereum Foundation. This year it's taking place in Bogota, in Colombia, in October. And we want to bring DevCon to Istanbul for the next year. And I hope you can check out our proposal, read out proposal, contribute to us, or even reach us out to me or Errol or Murat. And yeah, let's bring DevCon to Istanbul. So shortly about me again, I'm working at the Ethereum Foundation at Berlin. I'm working with the Solidity team, but I'm not working on the compiler. I'm working on a project called Sourcify. And Sourcify is a decentralized open source Solidity contract verification tool, as well as it's an initiative for human-friendly contract interactions. I won't go too deep into Sourcify, and you can follow me or reach me out from these accounts. So why am I talking about Ethereum's rollup-centric roadmap? I initially wanted to talk about Sourcify, but I thought it's a little bit a niche topic and it comes a bit technical, although this is also a technical topic. So I maybe thought it will be more interesting for you to learn about the Ethereum's roadmap, and as well as for me to learn about it as well. So if you want to learn something, just give a talk. Okay, so Ethereum is there. It's a great tool, but it has pitfalls. It has downsides at the moment. The first thing is the increased power usage. And as you all know, the blockchains, proof of work blockchains, Ethereum being one of them, is currently consuming a lot of energy, has a large carbon footprint. It's right now around 120 terawatt hours per year, which is close to a medium-sized country. I don't know the exact numbers now, but it's close to Netherlands, I think. But the problem is the consensus algorithm, proof of work, is designed to be energy inefficient at the beginning. So to decide on who gets to choose the next block, we rely on the hardware and the energy consumption. And from the beginning, it was actually planned to switch Ethereum to proof of stake. Like even 5-6 years ago, there were plans. You can see them. It's a Serenity roadmap, but it hasn't taken place yet because it's a difficult problem. But we think, at least the community thinks, as long as we can do that with much less energy consumption, that we should switch over to proof of stake at some point. Some other chains, some other people don't think it's right. They have their own reasons, but we think we don't need that much. We don't need a country's size of energy consumption to run a blockchain globally. The second thing is the network congestion. I guess you're all familiar with this. This was, I think, from an NFT mint. So like single OpenSea sale would cost like $3,000, or Uniswap similarly at that moment. This is taken from yesterday. It's much less now. It's much better, but still it's not acceptable, especially in countries like Turkey. People get priced out because of the current gas fees. And the third one is the increased disk storage. So this graph represents how much disk storage a full node requires. That downfall is because of the pruning at that time, but currently right now it's 800 gigabytes to run a Ethereum full node, and it's ever increasing, it's never going down. Okay, so we have the problems. So what are the solutions? How are we going to tackle this? But first things first, maybe you heard about Ethereum 2.0 before. We don't use that term anymore because it has like some misconceptions. It creates some misconceptions about Ethereum. There will be only one Ethereum. There won't be a Ethereum 1 and Ethereum 2. There won't be like two Ethereums. And Ethereum 1 will not cease to exist. Ethereum 2, if you don't know, Ethereum 2 was referred for the proof of stake Ethereum, but we don't use that anymore. And like the roadmap evolves constantly, and like we don't go Ethereum 2.4.1 or those kind of versioning. The Ethereum roadmap is always changing, and there might be also some confusion around ETH tokens, like what is ETH, what is ETH2 token. There might be some scammers. So we don't use that anymore. We refer to execution layer and the consensus layer. And on the way, until coming here, we gained some insights about how we can evolve. First thing is we realized we can modularize blockchains, so we can separate the concerns of what the system is doing into different parts, into different layers. I mean, technically they are not layers, but we like computer scientists likes calling things layers. So we have the execution layer, we have the data availability layer, and the consensus layer. Execution is concerned with what is the meaning of the data. Data availability is how to make the data available, and consensus is which is the correct data. The second thing we realize is that we can already start scaling via rollups, which I will be talking about, and that has how the roadmap become. So the first thing, the incoming thing is the merge. The merge refers to the merging of two chains of Ethereum, the execution chain, the current one, and the beacon chain, which will be the coordination chain for the proof of stake. So it has started with the deposit contract deployed on October 14, 2020. And I didn't know that, but it turns out that the deposit contract was funded by a random address with Tornado Cash, and it was created, and the rest is donated to the WikiLeaks. So we don't know who created the deposit contract, so there is no official author for that. And then the beacon chain launched in December 2020. And after a couple of upgrades, now we are waiting for the moment of truth when the merge is coming on this year, hopefully. And that means the two chains, the beacon chain, which is the proof of stake chain, and the current proof of work chain will start working together. And that means at that point, we will be running two different clients for two different things. The current clients, the Geth, Besu, Nethermind for the execution, and the consensus clients for running the beacon chain. What will happen post-merge? So the Ethereum's energy use will drop by 99.95%. So we won't be using a country's energy anymore. There will be lots of GPUs freed, and it's already happening. Lots of miners are switching off. And the beacon chain will set the stage for the sharding, one of the next phases. And it will make the Ethereum further deflationary. There won't be any more mining rewards, and you can see how it will happen in these links. Okay, when merge? When is it happening? We don't know, but we are getting close. So the last testnet to be merged is planned for 6 to 12th August. We don't know the exact date yet because there's a hash rate that will point the merge time, and it depends on the hash rate of the chain of the Gurley when the total terminal difficulty is hit. And when is mainnet happening? So it is again confirmed with like these confirmed certificates. It's that is happening in the ETH Berlin. So if you don't know, ETH Berlin is at mid-September. You might see some people that say it is not happening at ETH Berlin, don't trust them, it's happening at ETH Berlin. Just tell them the merge is happening at ETH Berlin. And yeah, it's a hackathon, and there will be a week of events in Berlin at that time, so make sure to check it out. Okay, so we talked about the increased power usage, and hopefully we will be solving that soon. What about the congestion and high fees? The second thing. So let's first talk about why it's expensive at the first place. So because Ethereum transaction fees is an open market, and there's just simply too much demand for the block space. Everyone wants to use Ethereum, everyone wants to do transactions on Ethereum. So why don't we just increase the supply? Why don't we just give them more block space, right? Because it's complicated. So as Ethereum, we want a global, credibly neutral system. There's this term, credible neutrality, that basically is being indifferent for things. It's a term, and it requires public verifiability, resistance to censorship, and being uncontrollable by one entity. And that means we want the network to be as decentralized as possible. And we need many independent validating users, and at the end, we have to optimize for the average user. So everyone should be able to run a full node themselves at home, and there's no shortcuts for this. So increasing block size, making blocks faster just means average user can't run a node. And this is from another chain. And if you can't read, the node requirements are a RAM of 256 gigabytes, a CPU of 16 cores, and yeah, I don't think these are a valid way to run. No one can run these at home, I believe. So we end up with this trilemma. So we either have to, from these three in a blockchain, we have to pick two. So if you want to be decentralized and secure, you have the traditional blockchains like Ethereum and Bitcoin. You can be secure and scalable, but not decentralized as the current high TPS chains, or you can be decentralized and scalable, but not secure with the multi-chain ecosystems. So we have to pick two, and the question is, how do we work around this? How do we scale without compromising decentralization and security? So we have to look where the bottleneck is. So at the moment, the bottleneck is at the computation, storage, and bandwidth. And we have to find clever ways how we use the blockchain to work around this. It's not the consensus. So the consensus we have is okay for a global system, but these are the main problems. So what if we don't have to compute every single thing that happened, or that not everyone has to store and share the whole data? Because currently everyone is doing the same thing. Everyone is having the whole history of Ethereum processed on their nodes. And this is the problem we are facing. And if that happens, the world will be a really nice place, but it's not easy. So how do we do scalable verification of computation? So what we do is we do not verify every single thing that happened, and we move the execution off-chain. We don't do everything on the main nets anymore. We push things off-chain to the L2s, to layer 2s, and we post all transaction data to on-chain. So things will happen outside, but we put summaries of what happened on-chain. And this is what we call rollups. And how do we know nothing's wrong? We introduce crypto-economic and cryptographic guarantees to what happens. Yeah, and these are rollups. It's called rollup because many transactions are rolled up and pushed to the chain. So it's like a compressed version of what happened on the rollup. And there are two types of rollups. One is the optimistic rollups, which uses fraud proofs. And this is a crypto-economic guarantee for the validity of what happened. It requires someone posting the result of a computation to stake a deposit. So they will have a deposit, and without a deposit, you can't post what happened. And we run the computations on the L1 only when there's a challenge. Otherwise, we, we, we assume everything is correct. That's why it's called optimistic. And the transaction data is posted on chain, so the smart contract on L1 can run and tell us the ultimate result. So if we really need to run something, the data will be already there to run. But we don't do this unless we really have to. Okay, but if we are like posting everything on chain, where's the scalability? Then what's the point? Because we are using fancy compression tricks to replace the data with computation whenever possible. So we try to compress the data as much as possible, and when we need it, we take the data and compute over the data and see what's the result. So we try to minimize, because we think we don't use it that much, as less as possible. We try to compress everything. So for instance, an Ethereum ERC20 token costs 45,000 gas, and an ERC token transfer in a rollup is 300 gas. A lot of compression. So yeah. And the second thing is validity proofs, which are ZK rollups. And this introduces a cryptographic guarantee to what happens. And it posts a ZK proof for the validity of the state transition. State transition meaning transactions. All transactions constitute a state transition on the chain. And it's expensive to compute, but easy to verify. And it's just magic, moon magic. And I'm not the person to ask what is here, what's happening here. I think there are a lot of intelligent, brilliant people here to talk about that. It's just magic. So the fees are already quite low compared to the mainnet. This is from yesterday, I think. And rollups are already here. So we should use them. What else? So we tackled the execution bottleneck. But then the next one is the data. So for the rollups, to further have lower fees, we need cheap data, and we need the data to be there. The data should not be gone. Because you have to have the data if you want to challenge or withdraw from the rollup. So we need cheap data and available data. What we do with the rollups today is we publish data directly to the layer 1, which is costly. And in the future, we will have special purpose data availability engine. So layer 1 will not only be an execution engine, but will become a data availability engine. Currently, posting data to Ethereum costs less because you are not doing execution, but you are using the call data for the rollups, which is much cheaper, but it's still a lot. So this is what Optimism has used for their data. So it's $3 million USD for 1 gigabyte of data on the chain. And the plan is to introduce data sharding. So before data sharding, we were talking sharding in general, execution sharding, what we refer as. We thought it's a good idea for Ethereum to do everything on 64 different execution chains. So we thought everyone will be talking to a different shard, and they're doing the transactions on the shard. But with the Rollup-Centric Roadmap, so now that we think everything will happen on rollups, we think we just need data sharding. So we don't need execution sharding at all, which is called dunk sharding. And yeah, the thesis here is daily usage will happen on the rollups and not Ethereum. And instead, the L1 will focus on being the best chain and a settlement layer for the rollups only. So it will provide cheap and available data for rollups. So it will provide cheap data with 64 data shards. And that means not everyone has to store everything. That's what we were wishing for a better world. But how do we make sure nothing's go missing? That's the problem of data availability. And there, the validators will be data availability guardians, and they will be downloading or sampling the random parts of the data available. And if you lose a data, or if you don't publish a data deliberately, you get slashed. You get slashed. And before the dunk sharding, until we get there, we actually have another proposal called proto dunk sharding, EIP 4844. This introduces a new type of transaction on the L1, which is not accessible to the EVM execution, but these transactions will not be executable transactions. They will be just data transactions, and they will be just stored as a data available for the rollups. Because we said, now that rollups dump everything on L1, they need cheap storage. And for a while, until we get to the proper sharding, we can provide a cheaper transaction for them. Currently, each block of Ethereum has 15 million gas. This proto-dunk sharding introduces another condition that you can either have 1 million gas or 1 megabyte of data on a rollup. So this can potentially give 100 times cheaper rollup fees. And but we still need to have full data, so there won't be sharding. Everyone will have the full data. And the nice thing about that is the data fees and the transactions fees will diverge. So we can have a different market for transaction fees, and we can have a different market for data fees. Which means, for example, an NFT drop clogging L1 will not have no impact on the L2 prices, because if you an NFT drop on L1 will only increase the prices for the execution prices. And since rollups are run on data prices, it won't be affecting the rollup prices at all. So yeah, the idea is that currently Ethereum has 15 transactions per second. If everyone moves to rollups, we'll have 3,000 TPS. And if we have the all 64 sharded chains, we can even move to 100,000 TPS. So these are just rough numbers. And yeah, at the end, we will have this consensus layer will run on proof of stake. Execution layer will run on, as usual, with rollup bridges and deposit contract. And the data availability layer is currently at, because now, previously I mentioned the TPS, but with rollups, now the scale, the measure of scale becomes the data, because the more data you provide to the rollups, the more scale you have. And now we have 7 kilobytes per second as data as execution with using cold data. Now with proto-dunk sharding, we'll have 85 kilobytes, and with dunk sharding, we have a megabyte per second scale. Okay, now the network congestion and high fees are also done, and we need to tackle the increased disk storage as well. There are several proposals for that, and these are more in progress, I would say. And this is the end game bottleneck. So at the end, after tackling all of this, we have to tackle the state's growth as well. Because right now, you pay once and something stays on the chain forever. So this is not really sustainable because it's ever growing. And there are two different proposals for this. One is weak statelessness. The other one is state expire, so the state can become inactive after a while. Or you can have the history expired, so that not all the full nodes have to serve everything. And the big picture is really laid out well by Vitalik in this visual, the roadmap visual. It has the merge, the surge, the verge, the purge, and the splurge. He divided the roadmap into 5 categories. So the merge is about the full transition to proof of stake. It's coming close. The surge is about providing more data to rollups through sharding. The verge is the statelessness and Merkle trees. The purge is eliminating historical data, what I talked about, history expiry, state expiry. And the splurge is everything else. Splurge is proposal builder separation, MEV stuff, those kind of things. So that's a good overview. And that's also from his slides. And it seems that his preference, or at least also most of the community's preference, is Ethereum to eventually settle down. So we are right now here at this point of the inflection. And after several years of rapid development, we want the chain to settle down. And ideally, we'll have so this y-axis is the capability of the system here. But ideally, at the long run, we want the complexity of the system to go down as well. Because we think and we hope most of the interesting things will happen on the rollups and L2s. And L1 will just do simple stuff and do the best for rollups to move further. So yeah, in the medium term, Ethereum will be all in on rollups. And there is this functional escape velocity thesis for layer ones. So that's when you have everything else on top without further changing the base. So you'll reach the functional escape velocity when L1 is complete for L2s to do everything else. We are trying to reach there. It's more or less a Turing completeness for blockchain. And yeah, the Ethereum L1 will continue to remain constrained and act as a settlement layer for rollups. And the execution will not run on the L1, but will be used by the rollups. So thank you for listening. Here are my Twitter handle, GitHub. Just if you have any questions, reach me out, find me around, and I'll be happy to take more questions. Thank you.
Thank you very much, Kaan.
That was a fascinating and very informative talk. Does anybody in the audience have any questions for Kaan?
I have a question. For example, optimism is just at EVM for now.
Mm-hmm.
They are running a blockchain especially. If, for example, in 10 years, they will have also problems like Ethereum because they are running the same EVM. So do we need the layer 3s in the end? So layer 4, layer 5, it goes like this, right?
Yeah, definitely. That's also one way to scale up. But I actually personally don't think rollups will reach that point anytime soon. So they won't be hitting those limits because they are already quite efficient and they can already handle a lot of transactions. But obviously we can go to layer 3, layer 4, anything else. Yeah.
Hey.
Hello.
Okay, I would like to hear your take on the development side of Ethereum. I mean, in your presentation, you have said that there are existing applications of, particularly also of Ethereum, such as rollups or proof of stake applications, etc. And do you think that Ethereum is taking it a little slow on applying those features itself? Because it's a very, very popular blockchain, and the other things are actually built on top of Ethereum.
Yeah, you can say it's slow, but I'm not sure if it's possible to further speed it up because we don't have many people that understand all those things. The main bottleneck is there, that there's no people that understand all of these on the protocol layer. Even I can give you an overview, but being a protocol researcher, working on a protocol level is real difficult. Second thing is the main reason, for example, the merge is now delaying all the time is basically Ethereum just sits on trillions of cash. So you can't just say, okay, we'll just move fast and break things. We can't do that in Ethereum. That's a whole different environment than a startup, than a usual tech company. We have to prioritize security and the security of the system. I think that's, I wish like if there will be more people working on Ethereum, there will be much faster development, but I don't think it's possible right now.